Tihe mōriora, ina mana, ina reo, ina hao e whā. Tēnā koutou katoa, tēnā koutou katoa, tēnā koutou katoa. Hello and welcome to today's Spotlight webinar, coming to you from our homes and respective bubbles instead of our Spark Innovation Studio at this time. Thanks for joining us. My name is Tony DeVries. I'm a product manager and emerging technology and IoT teams here at Spark, and I'm one of the hosts for this session. For those of you that are frequent flyers with us, you will find the format of today's webinar a little different. Firstly, I'll be joined by Dan O'Brien from AWS, who will be facilitating the discussion, and then we have a panel of speakers from Cropsey, Hector, Levno, and AWS. Dan will be introducing these panelists in a bit. Before Dan gets on with these things, I'll go through a bit of webinar housekeeping. Firstly, you're welcome to send in your questions to Dan during the webinar. Simply type in your question in the questions area on the right-hand side of your screen. We will be answering those during the facilitated Q&A session. Please note that this webinar is being recorded. You will receive a copy of the recording immediately after the webinar has concluded. Plus, it will be published on the Spark IoT website in the next day or so. Okay, let's get on with things. A little introduction to Dan O'Brien. Dan is a venture capitalist business development manager at AWS, with an ag tech startup as a focus. His mission has been to help Australia and New Zealand ag tech startups shine on the world stage by supporting them as they gain traction and scale up with AWS at their wing. Dan has also invested in startups at a venture capital in London, architected cloud and data analytics solutions in New Zealand and France, and raised capital at a high-growth consumer internet startup in Paris. Dan, welcome to the webinar. Great to have you here.
Thanks so much, Tony. It's great to be here. So hello all, as Tony mentions, I'm Dan O'Brien. I'm lucky to work at the startup team at Amazon Web Services here in New Zealand. And I help New Zealand venture-backed startups take on the world with AWS at their wing. And the cool thing is that we are seeing loads of startups take on some of the great challenges of today in agriculture, food and sustainability. I've been with AWS now 4 years. Initially joining as a solution architect before joining the startup team about 3 years ago. I also sit on the board of Agritech New Zealand, and like many Kiwis, have strong family links to the sheep and dairy farming community here in NZ. And it's exciting to see what customers are doing at the convergence of sustainability agritech, driven by the availability of data, compute, and connectivity. And what better example than computer vision and sensors in the field? It encompasses all of the above, giving superpowers to growers, farmers, and processors in the food sector. We are lucky to have a panel today to discuss just this. The questions around what would you do if you could scale computer vision almost infinitely? What questions could you start asking and answering if you had 1,000 sensors or eyes instead of 2 or 3 or 4 in your farm, your orchard, your processing facility? But really, what does it all mean? How can you jump on the bandwagon? Are you on the bandwagon already? On this webinar today, we are lucky to be joined by Kylie Hall from Hector, Oscar Ellison from Levno, Tony DeVries from Spark, your host, who's just introduced us, our very own Casey Orr at AWS, and Alia Alamori from Cropsey. So we're going to kick it off with 5 minutes of prepared remarks, a quick pitch from each participant, and then jump into a Q&A that I'll help facilitate. So without further ado, I'm passing the floor now over to you, Kylie, from Hector.
Kia ora, Dan, and thanks very much for inviting us to be part of this. Super excited. Hi, everyone. I'm Kylie Hall, lead storyteller at Hector and host of the Cohort podcast. Hector is an award-winning New Zealand-grown agritech startup, and we operate in the fruit tech space. At Hector, we support the success of fruit growers and packers across the globe by providing them with the world's simplest to use orchard technologies. We're in year 5 now of startup, and we're fortunate to have our solutions being used in 11 countries. And we've recently been named winners in the Global AgTech Breakthrough Awards. One of the problems we help to solve centres around the lack of early fruit size data that growers and packers have access to. When it comes to fruit, size really does matter. Different markets have different size requirements, and what growers get paid depends on how well they fit those sizing requirements. Now, traditionally, fruit growers and packers have had to use archaic manual tools, such as metal sizing rings and calipers, to gain early size samples of their fruit. These practices are time-consuming, they're inaccurate, they're not randomized, and due to the tiny sample sizes, they just don't represent the actual fruit in the bin. Critical decisions about sales opportunities, fruit storage, packaging, and labor are all made based on these early size profiles. Now imagine your sales team securing you a deal for your fruit. Hooray, you're finally going to get some money. So you have your team open up your costly cool stores, your forklift drivers whiz around collecting the bins of fruit, which have been deemed to be the correct size based on those tiny sample sizes. Your packers all get set in position, the packaging is installed, and you start running your fruit across your multi-million-dollar commercial grader. But it doesn't take long for you to see that the fruit is the wrong size. Everything has to stop. You have to start the process all over again and hope that this time the fruit is the right size. But, you know, maybe it won't be. Working with growers and packers in both New Zealand and the US, we continually heard about this problem, and so in 2020, Hectare launched Spectre, a computer vision AI fruit sizing solution providing sample sizes of up to 100 times greater than traditional practices, with accuracy levels of 95% plus, results delivered within seconds, and all straight from an iPhone or an iPad. Simply take a photo of a full bin of fruit, load it up into Spectre, and receive accurate size profiles from significant sample sizes within seconds. We use AWS to do the heavy lifting for us in the cloud, and our clients in New Zealand use internet providers such as Spark for their connectivity. Due to its portability and ease of use, Spectre has multiple use cases both in the field and in the packhouse. For example, Chip and the team from one of Washington's biggest apple producers are using Spectre in the field to assess how well they are picking to the sizing brief at harvest time. Gaining early size data from Spectre enables them to adjust the pick so that they can optimize their sales. And Christo from a major citrus packhouse in South Africa is using Spectre in the packhouse to reduce the number of costly stoppages that occur. Marco from South Tyrol in Italy is using Spectre in just a whole different way, and he's using it to keep his co-op honest. He has to send his fruit to the co-op for packing and sales, and the size of his fruit has an impact on what they pay him. He's a little concerned about how accurate the co-op is with what they're paying him, so he's taking control using Spectre to size his fruit and then telling the co-op what he's sending them. And Max from Central Otago works for one of New Zealand's largest integrated cherry growers. They're desperate to get their hands on Spectre so that they can take advantage of the golden hours of sales while the rest of the cherry market is sleeping. We've been totally blown away by the uptake of Spectre, and clever simplicity, our approach to everything we deliver, is really key. Just last week, in one day, more images were loaded up to Spectre than there were in the entire 2020 New Zealand apple harvest. Clever simplicity means creating outstanding, meaningful, and practical technology and delivering that tech with user simplicity at the forefront. We've got a number of exciting projects underway, and we're excited about the future and the part we'll be playing to support the people, the families, and the businesses that work in the fruit industry. Back to you, Dan.
Thank you so much, Kylie. That's really great. I love the way the different customers and all over the world are finding different ways to use Spectre and Hectare. It's incredible. So now we'll move on to our second guest, who's going to speak as well for 5 minutes, Oscar Ellison from Levno. Over to you, Oscar.
Kia ora, Dan, and hi everyone out there. It's great to be here. Just a little bit of background on Levno and what we do. We have a range of monitoring devices on farms in New Zealand. So we're on about 8,000 farms with a little over 12,000 various monitoring devices out there that talk back to the cloud. So we monitor milk vats, fuel tanks, water pumps, water tanks, effluents, and feed. And this information obviously comes on farm, we measure it, it goes up to the cloud where we process it, and then we send it back to a dashboard for the farmers. And we also send this to partners of the agriculture sector, like milk processors, and fuel companies and feed companies, so they know when what's happening on farm and can improve their logistics, and in the case of milk, improve milk quality by knowing how good a quality that milk is on farm. For the farmers, they get a dashboard of what's happening on farm, know if there's anything that needs to be addressed and fixed, and we send kind of real-time alerts. Livno, maybe I'll give a bit of background on Livno and kind of our history with IoT in agriculture. So we were founded in 2012. We originally specialized in the fuel space. So Larry, our founder, owned a fuel distribution company and saw the problem out there that he could know how much fuel was in every tank. They would know which tanks they had to deliver to. They wouldn't have to drive up long rural roads if there was no fuel to be delivered, and they could optimize their routing and logistics. We realized pretty quickly that there were quite a few challenges in this process, but once we were successfully pulling the information on fuel, we kind of looked at this agriculture sector and looked at what else we could measure. Got chatting to some of the team at Fonterra, who I see on this call, but talking about how we could monitor milk fats. And so that was our big second product. So we have a range of sensors that we put on milk fats, temperature, agitation, and volume, and can tell the farmer basically if anything's going wrong on that milk fat, and also send that information through to the milk processors. So back in 2019, Fonterra started to roll out the milk fat monitoring program at scale to all their dairy farms. And that really changed the game in the New Zealand dairy industry and farming in terms of IoT adoption. Basically putting an app in a lot of farmers' hands and seeing how technology can help them farm. So Livno now monitors half of New Zealand milk. We're expanding our offering into other products, water, effluent, and feed, and developments ongoing in all of these things. And we're looking to kind of new markets offshore. So speaking to companies in the UK and Ireland about how we can take our milk solution over there. It's really exciting to be part of the IoT space in agriculture. There's lots to measure on farm, and the kind of rate of adoption has been pretty massive in the last 8 years. And it kind of last year, for instance, Livno grew at over 100%, so doubled the number of sensors we had on farm. The kind of regulatory environment's one of those big pushes. So being able to actually measure the outputs, things like nitrogen levels, etc., means that you can kind of streamline rules and put a bit of creativity back in the farmer's hand and allow them to farm but measure the actual effects. So I'm really excited about the kind of future of measuring things on farms. We've always been about finding problems on farm that affect a large number of users and solving that problem en masse. So we think there's lots still to do, and with tools that are coming out both on the connectivity space, the computing space, the price of sensors is just massively falling. We're going to see a lot more sensors on farms, and farms are going to become increasingly monitored. So Livno is excited about the future and our role in that. Back to you, Dan. Cheers.
Thanks a lot, Oscar. I mean, you raised some really key points there around this convergence of the technology that's happening now, and the fact that things can be streamlined once you got the data, and a lot of the problems that there are out there today effectively can be streamlined, maybe around compliance and that thing around adoption. is incredible, the way the things are just being used much more readily nowadays. And connectivity is a big thing, and we've got a great person next up to speak about connectivity, Tony de Vries from Spark, your host today, who has a long experience in this domain. So over to you, Tony, to talk about what you do.
Kia ora, everybody, and welcome. As mentioned before, my name is Tony, and I work in the Spark IoT Foundation and Emerging Technology Squads, with a focus on improving Spark's IoT and 5G connectivity for our customers. I've been in the mobile industry for almost 30 years now, going from 1G to 5G, maybe I'll make it to 6G. Coming from the West Coast, I have a particular interest in rural mobile coverage. I've been involved in the RBI 1 and RBI 2 programs providing improved rural connectivity. Spark has a range of IoT connectivity options and solutions for agricultural businesses to help them become more productive and sustainable. These range from our mobile-based CAT-M1 and NB-IoT networks to LoRaWAN, which is great for locations where mobile coverage is not available. Spark CAT-M1 coverage is now also available on all the 265 plus rural connectivity group sites, which provides a significant increase in rural IoT coverage footprint for our customers. Spark also has the largest dedicated IoT team of over 40 experts to help agribusiness to win big in a digital world. Back to you, Dan.
Awesome. Thanks, Tony. That's 30 years is a huge amount of experience seeing the evolution that's happened in connectivity in the rural sector, which is great to have on the panel. Moving on now, we have from Amazon Web Services our very own Casey Orr. Casey, over to you.
Thank you very much, Dan, and nice to meet everyone. So just a little bit about me. So my day-to-day job within AWS is a solution architect, and more importantly, an account solution architect. So I work with small to mid-enterprise businesses, and that is really exciting to me because I get to experience a large swath of the New Zealand business ecosystem. So like on any one day, I can be dealing with helping customers do like simple websites like hosting, like they are just your standard free tier websites, for example, then all the way to helping larger businesses building out data strategies and the IoT sensor networks and how to actually manage those fleets. So I guess while this webinar is called The Rise of Computer Vision in Agriculture, I think that there is generally a rise of edge-based computing in all categories. It isn't very affordable or ideal to build a data center next to every paddock, orchard, or milk vat in the country. I think we can all agree that will be very expensive, which is why we have seen the uptake of specialized sensors or even solutions that use everyday objects like mobile phones and iPhones like Hector. That we can use for specific application environments. And as such, we've also seen an influx of amazing businesses, such as taking on the challenge, such as the ones we have here speaking to you. The recent plunge, as alluded to by Oscar from Levno, has in sensors and devices like the Raspberry Pi, or more pointedly for computer vision and ML use cases, the Jetson Nano or Xavier, has allowed affordable and quick prototyping of ideas, enabling a fail-fast, affordable, and iterative approach without the burden of excessive upfront costs. Although the chip shortage has thrown a wrench in that because the world is a complex beast. But you can get around it by using higher order services on cloud platforms like AWS and, for example, Rekognition to build out a proof of concept, and then and also use pre-built labels to extend that to actually prove out your idea and see if it's actually worth that extra level of investment to actually get that physical device, and the other investment of going the next step further and building out the ML model yourself to really get that price point down and affordable for your customers. Coupling this with the ability for edge sensors to be synced to the cloud platform, AWS is something that I always recommend. You can leverage cloud services to drive exception handling, notifications, custom workflows, analytics, greater insights with machine learning AI algorithms, and very important fleet management with remote updates or defect detection, because I think we can all agree that spending a weekend upgrading thousands of servers, sensors all over the country and the world would not be a fun endeavor. Performing more smarts at the edge allows for an ever watchful eye that can alert only when needed, saving power and communication for low power applications or rural applications, powered by the rural connectivity that Tony talked to, or sending footage or data at only relevant times to avoid storing hours of dead air every day in terms of like applications around security footage monitoring, etc. Being right next to action also means that we can remove the latency question when controlling actions locally. And we have all seen those multi-million-dollar sorting machines that can actually sort out, was it defective or wrong-sized like produce at incredible speeds. So if you're interested, feel free to reach out, and also you definitely ask questions. Back to you, Dan.
Awesome, thanks, thanks, Casey. Yeah, definitely don't want to spend a weekend updating thousands of sensors with the latest operating system and the like. But yeah, that point around the edge and edge compute is one that's so interesting. Edge connectivity and the cloud all working together, and that's something that is so applicable in the agricultural context. And so, without further ado, I will pass on to our last speaker from the panel. Don't hesitate to post your questions as we go through. So we have Ali Alumari from Cropsey. Over to you, Ali.
Kia ora, Dan. Hi, everyone. I'm Ali, and I'm the CEO of Cropsey. And at Cropsey, we're unlocking the full potential of vineyards with a unique and scalable AI-enabled vision system. This enables growers to achieve the impossible, understanding the needs and performance of millions of plants at all times and delivering insight-driven crop management to global enterprise companies. Each of Cropsey's hardware units attaches to the existing tractor, and the system sees and understands every single plant while a grower runs their daily crop operations. Profiling every leaf, fruit, shoot, cane, and trunk in real time as the tractor passes by. The result is a digital twin of the vineyard or orchard, accessed via an online dashboard. Maps clearly show areas of concern and patterns across the entire crop, so growers know precisely how their crop performs and changes over time. Cropsey's proprietary hardware opens an untouched realm of crop monitoring, and it's really grounded by growers' needs. The company is currently developing models to achieve early detection of pests and diseases, to target spray decisions and manage crop loss, measure yield to improve supply chain reliability, find underperforming and dying plants, so that allows for early and precise replanting. And finally, comparing pruning for every vine against the required spec amongst many other critical use cases. So each system sees and analyzes over 250,000 images per day as the tractor is going up and down the rows in real time. And the insights are sent over Sparks network to be visualized by the grower. And we're continuously developing and refining our AI models. And with the help of AWS, we've sped up our model development, optimization, and testing from months to weeks. And this has allowed us to rapidly test new models. We've tested our system in Marlborough and the Hawke's Bay regions. And so far, we've helped growers save a crop worth millions while helping others replace underperformers with precision at a very large scale. We're currently planning our pilot program for next season to continue proving the capability and achieve transformation in wine growing. Thank you, Dan.
Awesome. Thanks a lot, Ali. I mean, it's just crazy the way that we're getting individualized plant health. It's amazing to just conceptually think about that, and the amount of data that needs to be analyzed and processed. And that leads me to the next section. We're going to go to a Q&A now. So don't hesitate to post your questions or upvote questions using the question features of this app. And I just had one that I wanted to ask on that question of data and explosion of data and looking forward. If we think, 2025, not too far away now, with your customers, to anyone on the panel who wants to take this one, what do you see your customers, what a typical operation is going to look like in terms of the amount of data being captured and how that's going to be used? So does anyone want to talk about that? Say the number of sensors, the amount of data that's being captured?
Yeah, definitely. Kylie from Hectare here. I would certainly say that there's an explosion of tech adoption happening, particularly in the horticulture industry. It's certainly something we're noticing. The challenge will be that there will be so many different pieces of tech being taken up. And so one of the key pieces of work that Hectare is working on at the moment is how we can assist growers and packers to start bringing all of that together. So one sort of central hub, one view, and to then start generating insights coming from all of that collated data. So I think it will be a challenge to get to that point, and it will involve a lot of collaboration between different parties. But that's where we need to get to be able to deliver real value.
Yeah, that's fantastic. Yeah, the fact that actually collecting data and actually providing the insights on the data and the value from it are quite two separate things, aren't they? But the fact is you are collecting a lot more data, so you are going to discover problems as you go along that you can solve. Just before I go to the questions, and I will go through the questions in order from the upvotes, descending order. Anyone else want to answer that question about looking forward to 2025, say, and the customers you're working with and the differences from today? Sort of like high level, broadly speaking.
Yeah, I'll have a shot, Dan. Oscar from Levno. It still comes down to, as Kylie said, like it needs to be a problem that people are facing, and obviously the more people facing that problem or have the similar problem, the easier it is to kind of solve. And but what you're seeing is the cost to solve these problems. So the sensor, the communication, the compute costs all kind of plummeting, and things like satellite imagery, the quality of that's improving, etc. So all the inputs are kind of scaling down exponentially in cost, and so your ability to solve problems on farm is rapidly increasing. I think we'll see it double every kind of 3 or 4 years, or even faster than that. So probably on average at the moment, most farms would have 1 or 2 IoT devices, and by the end of the decade, it's going to be up in the tens, if not hundreds.
That's yeah, huge explosion. Great. Look, I'll unless there's anyone else who wants to answer on that one, looking forward, I'll move on to the questions from the list here. And the first question comes from Mark Daniel, and it's around connectivity. And it's probably most towards you, Tony, and here I'll read it out to you. Given that mobile phone connectivity in rural New Zealand is ordinary at best, what is Spark doing to offer acceptable coverage to farmers who want to use such technology?
Yeah, that's a great question. I think the key thing that Spark's doing is it's involved in the Rural Connectivity Group, which is the joint venture with the 3 operators and the government to roll out 500 mobile sites to rural New Zealand. There's places that I never would have thought would have got mobile coverage, and indeed the Chatham Islands, hopefully within the next couple of weeks, will have mobile coverage. So that program is rolling out right across the country. From where I am on the West Coast, I think there's now 20 mobile sites coming through that program. So I think that program is key to increasing the connectivity options in rural areas. We've also got solutions like using satellite backhaul and coverage in a box for LoRaWAN to create bespoke IoT coverage for customers, and then you've also got satellite options like Starlink and things like that coming along. So I think there's always room for improvement in rural areas, but I think it's getting a lot better than it used to be a few years ago.
Thanks, Tony. I'll move on now to the next question on the list from Bryce Simpson, and this is towards Oscar. Oscar, what metrics can you measure at present outside of volume?
Anything where there's a sensor, really. So with volume, we normally do that. There's 3 ways we do it. We use LiDAR or radar and measure it from above. So in milk, we kind of measure the height. In fuel, we use capacitance probes, so very accurate. And then we also use pressure sensors in some water situations. We have flow meters, magnetometers that can measure pump performance. And we've been playing around with soil monitoring. We can do electroconductivity. The sensor range is exploding. and kind of it's more kind of what's the problem on farm, and what's the best sensor to measure this. But it's pretty easy now compared to how it was 5 years ago to connect an off-the-shelf sensor to a device, and we have a transceiver on every farm, so you can get that information off farm. So if there's something that needs to be measured on farm, get in touch, and we'd love to hear about problems that farmers are facing.
That's great. Look, just on that problem on farm, and that's something that everyone here has talked about, that effectively staying focused on the problem. How long does it take you? I mean, because the art of actually learning about the problems on farm is not necessarily obvious. Like, how do you do that? How do you learn about those problems, and how long does it take you? Just a follow-up question on that. To deploy a new service to a.
Yeah, I mean, the data is ones and zeros, right? So. Yeah. If we look at our milk monitoring, for instance, it's pretty easy to get a distance, a volume, is a sensor, is the stirrer on or off, what's the temperature, but it's the combination of those three streams of data that get the really important insights. So it's a combination of all three of those that we use a kind of machine learning probabilistic model to detect if it's actually a milking event, or is this just wash, or is the farmer just doing something crazy? And then our kind of newest kind of alerts and problems that we've got is if there's a serious problem with the chilling, what's the ambient air temperature, and is that temperature increasing of the milk increasing towards ambient temperature, and can we kind of get in there and alert the farmer before that milk gets too hot and causes bacteria issues. So it does take huge bodies of data to kind of, and lots of talking to farmers, etc., to work out what's causing them issue, what's costing them money on farm. I mean, we get 5 million messages off farm per day in New Zealand now, so you can think about how big these data sets get. And then obviously huge data sets, you can look at problems across that. Yeah, that makes sense. Look, just on that, I'd love to get Ali's view on that. Like, how do you listen and hear about the problems on farm or on orchard or in vineyard, and how do you sort of integrate solutions into your offering?
So it's a combination of two approaches. There's short-term problems that are very clear, and there's long-term problems that are sort of driven by economic and regulatory pressures. So the way we approach functionality development is a combination of both. So in the context, say, of pest and disease, it's mostly driven by regulatory pressures by the EU to sort of have better sustainable processes and more targeted spraying approaches. Whereas, say, for something like replanting, that was motivated more by a particular customer wanting a particular piece of information based on something that we tried out. So it's a two-pronged approach, but how that relates to data, we have like a big matrix, which is like the list of features. And effectively, there's multiple things that go into this matrix, whereby processing capability is one of them, the costs of hardware is one of them, and then eventually you're able to understand what a particular feature is, how hard it is to develop, and what the potential returns are for the customer. And that's how we approach our feature development.
Fantastic. That makes a lot of sense. I'll move back to the questions list, and we're on to the third question from this list now from Chris Fairfield, and this is towards you, Kylie. Hi, Kylie. In regards to Spectre, does it work both off and online? If offline, replicates when back in contact range?
Thanks for the great question, Chris. It's a really good one. Look, lots of our customers and lots of growers out there, and even in pack houses, sometimes you just can't be in a place where coverage is working fantastically. So we have definitely scoped that out and built that into Spectre. So all you're literally doing is taking a photo on your phone or your iPad, and taking that off the full fruit bin. So once you're back in coverage, you just load that up to Spectre, and then all the work can happen and you'll have your results. So offline is not a problem at all.
Thanks a lot, Kylie.
Just to, Dan, to just jump in there as well.
Yep.
So having that offline capability and syncing when you're back in range is quite a common problem that we hear amongst the mobile application, especially because quite often, as Kylie alluded to, if you're working in a giant freezer, for example, it's very hard to get Wi-Fi signal in a giant freezer. They tend to be quite insulated for other reasons. So yeah, we do have a number of services that help alleviate that, like AppSync, for example, to actually streamline that syncing of data back up to the cloud to get processed once you're back in connectivity.
That sounds great. And effectively, also you can, on the edge devices, you can make inferences or predictions as well, right? From a machine learning model that's been trained in the cloud, built in the cloud, then deployed onto the edge device, right? So they work together, don't they? Fantastic. I'll move down to the next one from Tim Cutfield. Hello, Tim. What sort of latency is there in taking an image of a bin of cherries and getting the fruit sizing back to the phone? So this is probably directed, I'd say, towards Kylie, maybe Ali as well, but Kylie.
Yeah, thanks, Dan. Another awesome question. And I love cherries, one of my favorite fruits. So good to be talking about them. We developed Spectre initially for the apple industry, and then we had demand from the citrus industry. So we built Spectre for citrus. And now we've had demand from the cherry industry. So we're now piloting this November Spectre for cherries. We are able to deliver the results back from apples, for instance, right now within 4 seconds. So it is amazingly quick. It's literally take a photo, load it up, and you get your results. And it is literally that simple. Happy to provide you a demo anytime. Just look me up.
Thanks, Kylie. And Ali, do you want to talk about that one again? It's a question around, latency. Is there any latency in taking an image of a bin of cherries and getting fruit sizing? But I know it might not be cherries in your case, but is there something you'd like to comment on there too around latency?
So yeah, that's actually an interesting question because we're still getting our backend built. So aside from that, in terms of processing, everything is processed in real time, which then the latency becomes becomes purely around when you get reception. And the second you get reception, stuff is sent to the cloud. As of now, manually, it takes about, say, for a result to get back to us within the hour. For a feature that we've already developed. For features that we're currently developing, it's a continuing engagement with the particular customer, and that takes, say, a week or a month as we develop the model to detect the things and then redeploy it.
And I can imagine the images are pretty high resolution images you're dealing with there, right? In terms of large file size and the like.
About quarter of a terabyte a day per system. It's quite a bit.
Significant scale, yeah. Great. Let's move on to the next question. So Peter Adefonso, what features? Okay, right. So this is from AWS. I can't probably answer this because for our customers, what feature would you say is missing on AWS that you would like to see? Be honest and open.
Well, we're getting everything we need, so don't really have a lot to comment on that one. And we're always, speed is always really important, and we're always gaining great improvement on that front. So that's we're pretty well taken care of. The other guys might have something more to add on that.
Yeah, AWS, we made the move to cloud computing a couple of years ago, and it is great because it is scalable and just does what you need it to. The problem more is working out what the best tool is for the job, and there's a range of tools on there. So like one that we're just about to start playing with is TimeStream, which is really good for IoT kind of time-based data. but yeah, it's pretty easy to get into AWS and start. I'm doing an AWS sales pitch now for Casey and Dan, but it's been good for us. Yeah.
Cool. Just saying that, there are 200 plus services there, and we've got Casey and the team here in New Zealand and around the world really to help with navigating, and effectively don't hesitate to get in touch on that. Similar, I'll give an opportunity to Tony to speak as well around connectivity. If a customer's looking to use connectivity with Spark, what should they do? What are the first steps?
Yeah, thanks, Dan. Yeah, so we've got starter kits for our customers. So if they want to trial IoT, we've got our LoRaWAN and our cellular-based one. So basically, we can give you some SIM cards and some data and get you started. So you just jump on our website and sign up for one of our starter developer kits, and we'll send it out to you within probably a week. And we've also got a team of experts to help out as well. So, as I said before, we've got over 40 dedicated people in our team on IoT, and we've got a vast amount of experience helping customers. So, just reach out to us.
Cool. Right, so the last question on this list I have here from Stuart Simmons. Great presentations. Did each of the presenters pick their own computer vision product, or did Amazon Web Services have a service that they could use? So we'll expand that not only to computer vision, but sort of data analytics, so also from the Levno perspective. But I want to hear from you. Yeah, effectively, did you pick a product, or did you use a service as such from AWS?
Oh, we so insofar as what we've developed, do you think that's how the question's coming through, Dan?
Yeah, I think that's the question. So we're talking about computer vision, and so Spectre at Hector. I'd love to hear, how was it developed? The background story. Yeah. So
Spectre was purely driven from recognizing a problem with an industry. We are still hearing so many different problems that growers and packers face around the lack of size data. Trucks backed up in their receiving lines because their people just can't get through their manual processes that they've traditionally done at a decent pace, and not being able to make decisions about how long to store things for, and having to stop your packing line where throughput is everything when you're running a packing line. So Spectre was purely driven from having those conversations with industry and really understanding what those problems were and the multiple use cases. I think that was really critical for us to gain really good clarity around the volume of value that could be provided by something like Spectre. So that's how it all originated, and then we started capturing imagery and building from there.
That sounds good. So I think the question's also alluding to, did you use an off-the-shelf sort of service from AWS? Like, we've got a service called Amazon Recognition for image recognition, but in fact, I believe in your case, it was your team actually developed its own proprietary computer vision model, correct?
Correct. Wanted to thanks, Dan.
Yeah. And Ali, as well, from your side, do you want to comment on that as well, in terms of off-the-shelf use versus a service use, or rather than a sort of building your own IP and proprietary technology?
So a lot of the problems we're solving are quite niche, in the sense that it's within the context of AgTech and within a particular crop. So we tended to leverage SageMaker a lot in the early days, but not necessarily use the innate features of SageMaker that were pre-built, but to take everything that's been built and then adapt it to our current use case.
Cool.
And that's been, so far, that's how we've done everything. And through that, we've managed to reduce development time by at least a magnitude or two. It was awesome.
That's great. Casey, do you want to just describe what Amazon SageMaker is a little bit? Or?
So SageMaker is sorry, Casey, I think you might be better off.
Yeah. No, it's always good to hear it from the customer as well.
Yeah.
So in effect, SageMaker is like a platform, effectively, that allows you to train develop and optimize your models, and also run inference. For us, we run inference on edge, so we mostly use SageMaker for model development and optimization. And through that, we've managed to not, like we're using a rig that costs 80 grand, but without having to pay 80 grand up front, we just pay hourly, right? So through that, we've managed to develop models very, very quickly that otherwise would have taken us months to train in this span of weeks.
SageMaker really helps with that cost management side of training, because it will aids with you spinning up spot instances, doing all that training and these really large machines. And then once you've done the training, it just gets rid of it. So it really streamlines the whole process. That's
great. And effectively, startups can benefit from the AWS Activate program for startups, which provides up to $100,000 worth of credit to offset charges for as you build your models. So you can talk to us about that if you like. Cool. I see there's been a question upvoted here that I will take from Hannah Mitchell. With all this automation, are we going to see a loss of jobs? Does anyone want to take on that one?
I'm happy to jump in and give that one a crack, because I think it's a really valid concern that is held by many people. But the reality is, when you look at industries like the horticulture industry, 75% of people in the industry are concerned about scarcity of labour. So if we can use computer vision and technology to relieve some of the human manpower from some of the tasks that could be done by technology, then that frees them up to actually use the labour supply that they can access for the really critical, important tasks. So that would be how I would answer that and how I would view that.
That's a positive perspective. And Oscar, do you have something to comment on that?
Yeah, I mean, I'd just add to that. I think Carly's hit the nail on the head there. It's the first problems that we're solving are the easy problems to solve. So it is the kind of mundane tasks. We often talk about at Livno, it's one less thing to worry about. You don't have to check that tank. You don't have to, go for a walk and get out on the motorbike and check that pump's still running. So it's really taking those simple, boring tasks and allows the farmer to basically lowers their anxiety levels and focus on really making the farm more productive and focus on the important parts of the business. So yeah, overall, I still think technology is a very positive thing and is far more helpful. Yeah,
that resonates. Effectively giving people more time to do more things, right? And yeah, it makes a lot of sense. Does anyone else want to talk about that? It is a big question around social license. With all this automation, are we going to see a loss of jobs?
There's also a big part of it, which is the analytics side, and humans just don't have the bandwidth to chew through millions of data points or even collect millions of data points. So you almost the analytics, the insights, the optimization, the forecasting pieces that run these actually run in parallel with the existing operations, not necessarily replacing certain parts, because it's allowing you to achieve impossible things before. I mean, in the context of Cropsey, you need an army of 10,000 scouts just to achieve the same collection capability of 2 or 3 systems. So that actually runs in parallel, and it might even enable the scouts themselves to focus on different things that are, say, instead of actually doing manual sampling, focusing more on analyzing the reports and then driving decisions off the reports.
That makes sense, and then could well be creation of jobs effectively, right? And especially as the technology is exported overseas, as you discussed, that customers overseas adopting this technology too. Does anyone else want to comment on that? Otherwise, I'll come to another question I had in mind, because I think we've gone through all on the list here. I'm just scanning the list. Yeah, we have. I've got one more, but anyone else want to comment? Tony or Casey? No. Casey, yeah.
I think everyone did cover off the key points, but the one example I always use is that custom DevOps deployment pipelines for services and servers. I don't think anyone that has been an infrastructure or developer has ever missed doing manual deployments to servers, especially at 2 a.m. On a Saturday, which is the general window that people used to do them in. So they can actually now take that time to actually, have a proper sleep, sort of fresh on that Monday morning. But it's just one less thing that they need to worry about in the day-to-day, is whether or not that release is going to succeed.
Yeah.
And also they can start focusing on actually delivering more value to the business. So it's just
some of that mundane work and the like. Yeah.
Yep.
Cool. Look, I just want one more question from me. I think we're going to wrap up soon. But I want to talk about, the big thing is sustainability, again, around social license and not only improving yields, which is something we need to do effectively to, the great challenge around feeding more people on the planet by 10 billion people by 2050 is what they're saying. But also doing it in a sustainable manner. I wanted to ask if anyone wanted to comment about the importance of sustainability to what they're doing.
Our internal motto is to make sustainability economically feasible at Cropsy, and that's through effectively providing the information necessary to begin challenging some of the traditional approaches that have been used in order to effectively get to this point. But at the moment, if I tell someone don't spray as much, without providing evidence, it's an extremely risky endeavor. But if I show objective evidence of exactly what's going on, then there's that confidence to achieve a more sustainable process because you actually have the information to support it. So that's a big driver for us, is that we provide the information to de-risk achieving a more sustainable operation. That's great.
Yeah, I would add to that, Ali, too, by saying that, helping businesses to be sustainable themselves is really critical. Businesses these days, particularly in the growing sphere, are just coping with so many challenges now. And, you've got extreme weather events, which used to happen every 100 years, which are now happening every 10 years or even less. You've got soils which are depleted. You've got less land available. And, scarcity of labor is massive. So, supporting businesses to be sustainable as well as them to achieve their own sustainability targets, I think is it's one of the reasons we're here.
Sure.
Yeah, I'd add to that and just say, obviously, agriculture so often gets a beat up on bad farming practices, etc. But being able to measure these things accurately and in real time gives the farmers the tools to improve their systems. And New Zealand in particular, our role in global environmental issues, we can take a leading role in the agriculture and horticulture space. So IoT is going to be a huge part of that, correctly measuring things like nitrate use or fertilizer use and optimizing that. You can't do that with farmers would like to say they can look at a paddock and know when it's going to rain and how much of X they should be applying, but these huge data sets are what gives them the tools to do that correctly and optimize that. So massive role for IoT and all the companies here to play in making New Zealand's agriculture and horticulture more sustainable.
That resonates really strongly. Tony, you have a point?
Yeah, absolutely. Our IoT purpose includes sustainability because, as you said, the social license, and we're just seeing a lot of interest around the country for sustainability solutions. Water quality is way up there. So yeah, a lot of interest in making sure that agribusiness is sustainable for going forward, because we have to be that way. Otherwise, yeah, we won't be. It'll be a tough place to be in if we're not sustainable.
Absolutely. Look, I know we are running close to end of time. I wanted to, Tony, I've already asked you about how people on the line can get started and a call to action. I just want to ask Kylie, Ali, Oscar, if you had any, quick things you want to say to the audience before I'll hand it back to Tony to wrap up. And any call to actions or asks. Yeah.
Yeah, thanks, Dan. I think, a lot of the work that we do and the software and solutions that we've developed have all come from talking with people. So talk to us. Yeah, we'd really love to find out what the challenges are that you're facing that we might be able to help with.
Ali, over to you.
Yeah, I mean, at the moment, we're already planning our pilot program. So if you have a large vineyard that you'd like scanned very, very frequently and know everything about it, let us know.
Cool.
Yes, similar from us. It's just knowing what problems that people out there on farm are having. There's too many problems out there for us to solve as well. So more people in the ag tech industry in New Zealand, I think, as I said before, we've got a place to play globally. So if you see problems on farm, get out there and start solving them.
Perfect.
Let us know about them. We'd be happy to take a look.
Thank you very much, everybody, for a great discussion now. I see we're 4 minutes to 11, so I think we covered some wide-ranging topics. I'm going to hand back over to Tony. Just the same thing from us, from Casey and I at AWS as well. Get in touch if you want to talk. We've got a New Zealand team here. Always love to hear from our customers and talk to you about potential problems that we can help with. So over to you, Tony.
Cool, thanks, Dan. On behalf of the Spark Innovation Studio, a big thank you to all of our panelists. We really appreciate you giving up your time for today's webinar. Also, thank you to Dan from AWS for being such a great facilitator and sharing so many insights with us. As I mentioned, we are broadcasting today from our homes instead of the Spark Innovation Studio, which showcases IoT, 5G, mobile edge computing, and other technologies. If you'd like to come in for a tour of the studio once we get to alert level 1, which is hopefully soon, please email the team at innovationstudio@spark.co.nz. And just as we wrap up, I would like to thank everyone who has joined us online and participated with questions. Remember to check out the website, spark.co.nz/IoT/webinar to see what other webinars are coming up and to register for those. There will also be a recorded copy of this webinar on the website for you to view and share with your colleagues and friends. From me and the Spark Innovation Studio team, kia kaha, kia mea, kia mana wanui.